Hello, class, the receiving students and teachers. Thank you. You may be seated. We're still with the same strand, same substrand, outcome, and unit title. Now, our topic for this lesson is electric circuit 3. You have the receiving students and the teachers, as well as the model class. You have already received the lessons on electric circuit 1 and 2, and I hope you have learned so much about electric circuits. Now, in electric circuit 3, this lesson, we will be using some equipment or apparatus that I would like to show the class as well as the receiving students before we go through our lessons as well as the experiment. Now, firstly, we have the ammeter. This is our ammeter. Now, the ammeter, this is the ammeter, and this ammeter is used, it's an instrument used to measure the amount of electric current that flows through a circuit. We also have the thermometer. You all know very well of thermometers that are used in the hospitals. Now, the thermometers that are used in the hospitals are smaller and different. They are used for measuring body temperature. Now, the thermometer we have, this is the thermometer that we are going to be using to measure the heat that is produced by the circuit or by the electric current that will flow through the circuit that we will be using in our experiment for this lesson. Now, I also have this one. Okay, this is a resistor or heater. We are going to use this as a heater to help to produce heat for the water that we have in this container. Now, materials that you will need, I have the list on the screen. You were reminded, teacher, of these materials in the previous lesson that you received on electric circuit 2. Now, we have the diagram of the setup of the equipment or the apparatus that we will be using for our experiment. And teachers, I would like you to take note of this diagram that is on the screen. And I have one setup which I will be showing you shortly, but that is how you should set up the apparatus for this experiment. Let's look at what the heater is, the heater that we are going to use. We see what the heater, have a closer look at the heater, what it's made up of. We have the diagram of the heater, and we have an insulator that covers the heater. We have bare wires, and those wires are conductors of heat, good conductors of heat. We have coiled nichrome wire that is at the bottom of that heater. So that is a closer view of the heater that we will be using in our experiment. Now, our instruction, the first one, it says we are to set up the experiment as shown on the screen or the worksheets, the students' worksheets. Now, you have seen the diagram of the setup of this experiment, especially the apparatus. You've seen that, and I would like to show you the one that I have on the table with me. So what you have seen on the diagram, it should look like this when you are setting up the apparatus. Now, if I can have other students, if you can get yourself ready to carry on with this experiment. Now, I'd like us to have a look at our instructions. The second one, it says you are to take the reading of the thermometer at start. Now, to do that, let's have a look at the big chart that I have on the whiteboard. We will be starting with 2 dry cells. Now, teachers, if you look in your teacher guide, you will see that we have 4, 6, and 12 dry cells. Now, I've decreased the numbers, and we have 2, 3, and 6. Now, for the second instruction, you are to take the reading of the water temperature at start. Now, before the experiment, you start doing the experiment, you take the reading of the temperature that is on the thermometer and record it where it says 0. Then you are to put on the switch and record the reading on the thermometer after every 2 minutes for 6 minutes. Now, with us, we don't have an actual switch. We are using this as our switch. We have these connecting wires with crocodile clips at each end. So these are going to be our switches. We will be using this as our switch. Now, please, teachers, take note and help your students in how to find the degrees Celsius for each of the readings. To find that, you are to subtract the first reading of the water temperature from the second reading. Then record the readings in the table that you have on the worksheets. An example, we have a bigger one here on the wall. Now then, assist the students to give their responses to the statements on the experiment done. Okay, if I can have the class to get yourselves ready so we can carry on with the experiment. Okay, thank you. If I can have you all. Teachers, every student has a role to play. One student will be the timekeeper who will check on the time. Because we are working with time, we have 2-minute intervals to do the reading, so there has to be a timekeeper. We also have a student to read the temperature on the thermometer, another student to put the switch on and off. We've already shown you the switch that we are going to use. We also have another student just to check on the ammeter to see that it's working. Now that helps to show that there is flow of electric current in the electric circuit that we have. Another will help to make sure when we come to especially changing or increasing the dry cells, there has to be a student to help with that. Now for this experiment, teachers, we will only do the first one, that is the 2 dry cells. And I'd like you to continue with your students to do the 3 dry cells and the 6 dry cells. Okay, so if I can have the class to get yourselves organized, and you can start now. Let's have the timekeeper. Eddie is the timekeeper. Okay, the reader, thermometer reader. I think you come over here. You can see it clearly over here. Yeah. Okay. Okay, then. Now, who is keeping watch on the ammeter? Will be with the switch, operating the switch. Then you have to come over here. Come here, sorry. Okay, the recorders, you stand there, so you give, yeah. She tells you, and you do the recording, okay? And you have a marker here. So once you get your reading, you go and record it over there, okay? Now we have our students ready now. So firstly, let's see, they're going to take the reading at start, water temperature. Water temperature at start. You have to go down so yes, you see it clearly. Yeah, tell her. Okay, you have it recorded quickly while they're doing it. Record it, do quickly. Okay, you're going to do the first reading now, and don't forget it's 2 minutes for the first reading. Okay, let's start the first reading. It's 2-minute interval. You looking at it? Diane, can you see it clearly from here? Have you connected it? You should be getting the first reading now. Keep watching. Okay, now we are on to the second reading. Receiving students, please don't forget you keep on recording your friends, having the readings recorded, so as they do, you do the same. Diane, can you keep on checking? Check the temperature. Receiving students, I hope you also know how to get the degrees Celsius. I've gone through that earlier, but I'd like to repeat that once again. To get a degree Celsius, you subtract the first reading of the water temperature from the second reading, and whatever you get is the degrees Celsius. Now, in this case, we already got our first reading, and our temperature at start, it's already there on the chart. I hope you've seen that. And then we have the first reading. So you subtract the temperature at start from the first reading. You should have the answer your friends have, or your answer may be different from what they have. We will check on that when we complete our experiment. So I hope you are in tune with us. And teachers, please help your students as they work along. How is it? Okay, second reading. Timekeeper, I want you to get ready for the second reading. We're going to start the person who's reading the temperature. Don't forget, receiving students, our time interval is 2 minutes. After every 2 minutes, we are taking the reading of the temperature, the water temperature. Oh, you can see the temperature. We should be now on the last reading for 2 dry cells. Reading now. Okay, now you should find degrees Celsius. And teachers, as I have told you earlier, I'd like you to work on the 3 dry cells and the 6 dry cells using the steps that we have used to find the water temperature as well as the degrees Celsius. Now, I'd like to have the class to discuss quickly. There are 2 responses that you have, or 2 statements that you have, and you are to quickly discuss on your findings and also have a summary of what happened, what will happen when the number of dry cells are increased. Okay, if I can have you to discuss that quickly, and we'll have your presenters to present your findings. Okay, let's have you people go this way, so we'll have who is going to do the presentation. Okay. Okay. Okay, let's have, okay, you all go to the side, so we have Eddie to do the presentation. We're going to have Eddie to explain to us of their findings of that experiment that they did with the 2 dry cells. If you want to use the table, we have the results table, Eddie, the big one on the chart. So if you would like to use that, you can use that to do your explanation of your findings.
The temperature of thermometer increased by 2 after 2 minutes. When we use 2 dry cells, before the time starts, 28.1. After 2 minutes, it went up to 29.0. Okay. We need it after every 2 minutes. It increased by 1 degree Celsius.
So, Eddie, if I can have Michelle to sum up what they have from that experiment on the 2 dry cells.
The smaller the number of dry cells, the slower the electric current flows, And number 2 is the larger, or as we increase the number of dry cells, the faster the electric current flows.
Okay, good. Thank you. Michelle, we only did 2 dry cells. We are yet to go on to the 3 dry cells and 6 dry cells. We will do that to find out more. How do you know that if you add on more, you will have the temperature will increase?
By observing what we've just done here, since it took a long time to see the temperature increase by these 2 dry cells. That's why if 1 more was added, the current would actually increase too, and so it would go a bit faster. And according to our table there, you can see that there's no big difference in increase by degrees Celsius. That's why it only increases smaller or slowly. Yeah.
Very good, thank you. Good explanation, Michelle. Thanks very much. Thank you. If I can have you all to sit back in your seats from the experiments, you put whatever you have away. So we can go quickly through our summary points. So if I can have you to quickly have that summary points copied as students in the receiving schools, if you can have that copied quickly into your worksheets, sorry, your workbooks. It says the heating value of heat depends on the amount of electric current flowing through the circuit. We've just said Michelle did a very good explanation, and we have that as one of our summary points. Teachers, you should also be taking those summary points down to use them for your revision activities on the lessons that we will be going through the week. We have our second and third summary points up there. The temperature of water rises with time. We have seen that on the chart recorded by the model class. Our key phrase for this lesson, we have greater electric current, greater heating value. Value is actually talking about the figures that we have. We've seen that they increase. Now, our next lesson, teachers, the next lesson that will be on air is resistance 1. And teachers, these are the materials that you should have prepared, so you can, as you view the lesson or you receive the lesson together with your students, you should be able to carry out whatever experiments or activities the class will be doing together with your own class. And with that, thank you all for your participation.